Hi, teacher King. Apiwit. I'm doing exploring the night sky in the assignment 3 and presented by Apiwit. I'm the only one member. Okay. So first about the celestial equator and ecliptic. So I want you to welcome to exciting journey into the night sky, and then first let's discuss the celestial equator and the ecliptic. The celestial equator is an imaginary extension of Earth's equator into the space. And then while the ecliptic is the apparent path the sun takes across the sky over the year. So this is the sun, and they will travel around the ecliptic. So it's just the imaginary. So like of course the sun is not travel over around or maybe orbit around the earth, but the earth would orbit around the sun, but this would be like just the imagination. Yeah. And the 23.5-degree tilt of Earth's axis causes these two parts to intersect at an angle, which is why we have seasons. Yeah. And then there will be 4 point. Yeah. So there will be autumnal equinox, winter solstice, summer solstice, and vernal equinox. And I will explain furthermore. Yeah. Next is about the equinox and solstice. So first is equinox and solstice are key markers in our journey around the sun. On the equinox in March and September, day and night are equal because the sun is directly over the celestial equator. While in the contrast, during the solstice in June and December, the sun reaches the highest or the lowest point in the sky, resulting in the longest and the shortest day of the year. Yeah, and I will elaborate more. So vernal equinox. So this time the sun crosses celestial equator northward. While the autumn equinox, it will be have a relationship in the opposite way. So basically, the sun will cross southward. While another type, the solstice, this time they will have the longest day and the highest declination. I will talk after that what is the declination and the shortest day. Yes, the lowest declination. Next, I will talk about the daytime and nighttime in each season. So basically, everyone knows that summer have long days and short nights, while winter have short days and long nights. But the equinox, on that day we have the equal time of the equal amount of the day and the night. So the tilt of Earth axis affect the length of the day and night. In summer, days are longer and the sun takes a steep path across the sky, while in the winter, days are shorter with a shallow sun path. So during the equinox, day and night are evenly split, so the sun rises due to the east and sets due to the west. Next, I will talk about equatorial coordinate system. So the reference point is the vernal equinox. So this is the reference point, and the plane is the celestial equator. Yeah, so celestial equator is the plane of yeah, and then the declination is the angular distance from celestial equator. While the right ascension is angular distance east from vernal equinox measured in hours. So this will be in degrees Celsius. In degree, not Celsius, and this will be in hours. So to locate objects in the sky, astronomers use the equatorial coordinate system. So they will use this system. So basically it's similar to latitude and longitude, but projected onto the celestial sphere. And declination measure how far north or south a star is from the Ceres equator, while the right ascension measure how far east a star is from the vernal equinox. So like when you just see this, like when you just learn about the theory, you may not like know what is this. So we will like talk about like I will show you the DIY experimental, so you will like deeper in understanding about it. And the last one is about the identifying circumpolar stars. And so basically they are like, so this is just like the how to find of it. If you like point, yeah, with just only one finger it will be like 1 degree Celsius. If it's 3 fingers it's 5 degrees Celsius. So this is like one of the way that you can measure like the declination of it. So like if you know that like on that time the star is uh uh 5 degrees 5 degrees, so you need to use 3 fingers, and then you will know that like this star will like on around that point. Yeah. And next I will demonstrate you about it. Have you ever wondered how we can map the stars and celestial objects onto a sphere? Let's give it the simple DIY celestial sphere to visualize and elaborate these concepts and explore the night sky. And then I get this one, DIY celestial sphere. First, the dark orange one is the ecliptic line. And this one is the north celestial pole and north celestial pole and south celestial pole. This one is called vernal equinox. This one is called summer solstice. This one is called autumnal equinox. And this one is called winter solstice. Yes. And there are like some people point in the earth. So I would explain so wait, this one is the declination. Like you have 10, 20, 30, 40, 50, 60, 70, 80, and 90 is the max, while on the south hemisphere is -10, -20, -30, and the right ascension, as you can see, you will see like 2 hours, 4 hours, 6 hours, 8 hours, 10 hours. So this is the right ascension. Yeah, I would elaborate the first one first, the vernal equinox. So equinox is you have like the day and night equal, and it's located on this point. Yeah, with the declination 0 degrees and 0 hours of right ascension. Yeah. And next one is this point, the summer solstice, with the declination 23.5 degrees with an right ascension 6 hours. And this point is located like the opposite side of the vernal equinox. It's called autumnal equinox. Yeah, this point. So basically this day is like they have an equator. Oh sorry, I haven't tell you that the summer equinox they have the longer days, like the longest day, and shortest the shortest night time. And lastly, about the last one, the winter solstice. So this one have the shortest daytime but longer night time. And this one will be located at a declination of negative 23.5 degrees and the right ascension around 18 hours. And another point about the pointing the stars, like if you know the altitude, like for example, you know that like the star on that time is around 5 degrees, so you can use the 3 fingers like this and point like this. So you can know that like the star will located around here, and you can use like the stellar application and point into that position so you will know it. And the second example, if you want to do like 30 degrees, you can do by adding another fingers like this. So this one is 25 and this one is 5. So if we add it 25 plus 5, it will be 30. So you can point the stellium application into into this finger, and so you will see the star that you want. So this is like just the easiest way to find the stars. And if you have further question more about it, you can like research and do the deeper knowledge about the celestial sphere. Thank you for listening.